Hi, this is Ida Quita, and welcome to episode 5 of the walkthrough of the HackerRank C language track. In this episode, we'll be going through the for loop challenge. Note that all prior episodes are available on a playlist on YouTube, and if you haven't watched those, certainly go do that. In this video, I'll point out C++ tips and potential pitfalls, and you really need to do this code yourself to get value out of the challenge. So be sure and get a HackerRank account of your own so you can do this your own. Follow along and do it yourself and learn. Yay! Also note that the website and all content from HackerRank is their copyright material, which I'm using for educational fair use purposes. Here we are, the for loop. One of the things computers are really good at is doing the same task over and over again on slightly different data or on very different data, without getting bored or making mistakes because of the repetition. And humans are terrible at that, so this is one of the places that computers are really useful. Well, in order to do that repetition, there are statements in C++. One statement like that is the for loop. It starts with the keyword for, and it has 3 expressions to define the length of the loop. The first one says, what are the initial values? The next one says, what is the condition under which we continue to loop? And the last one says, how do we change the variables in between the iterations of the loop? Each trip through the loop is called an iteration. Well, before we go too much further in the for loop, I'd like to introduce the while loop, because the while loop is very similar in its appearance to an if statement. Here it is. Notice that a while loop looks almost identical to an if statement. It's really just 4 letters different. And just like the if statement, when we get to the while loop, we look at the condition and we say, is this condition true? And if it is, we're going to execute the block of code that's associated with the while loop. But this is where the difference comes. When I get to the end of that block, I come back up and say, is this condition still true? And if it is, we go through the statements again and then ask that question again. And if the condition isn't true, then we just continue on. If we'll look at the for loop, it has a very similar structure as we saw before. But one thing I want to point out, in practical terms, when you use a while loop, you're going to initialize some variables before you ask the condition, and during the block of code, you're going to update some variables that affect the condition. And that's just like the 3 expressions in the for loop: initialization, a test of the condition, and the update. Let's compare how a for loop and a while loop would look doing the same thing. Here I want to go through a loop 10 times for all values of I from 0 through 9 inclusive. We start at 0, and if I is less than 10, we do the stuff inside the loop, and we increment. That's the plus operator. That's a post-increment operator. It adds 1 to the variable, and it gives us the value of that variable before it added 1 to it. Here in the for loop, we have the same 3 pieces. We have the initialization, the condition, and the update. Both of these loops would loop through the same number of times, and they would do the do stuff 10 times. They have the same components, just arranged a little differently. Fors are great when you have simple and fairly numeric boundaries. Whiles are great when you have complicated boundaries where the code to update the condition might be complex. Well, let's use both of these to implement the challenge. Well, what is the challenge? We're going to be given 2 positive integers, a and b, separated by a new line. And then for each integer in the interval, we are going to do the following. We're going to print the English translation of that digit if it's between 1 and 9. And then if it isn't less than 9, less than or equal to 9, it'll do something else. And that looks really familiar, and it is really familiar. We're actually going to not write that code again. But more on that in a second. First, let's add our documentation. Given 2 positive integers, A and B such that A is strictly less than, not strictly less to, in fact, A is less than or equal to B. Separated by a new line. That means we can just use CN because white space is a separator in CN, and a new line is valid white space. And then for each integer, we're going to do something. We're going to translate. Okay. Before we go any further, let's make sure we know what we're doing on the loop. And to do that, we're just going to write a skeleton of the loop. First, we need to get the input values. We need some place to put them. Two integers, and I'll call them lower and upper for the lower and upper bounds. And we'll simply use CN to get lower and to get upper. They're separated by a new line, and so the white space requirement to separate for CN is going to work for us. If we're concerned that we haven't read them correctly, we can dump them out to standard error like this. C error is one of the best ways to be doing debugging on HackerRank. There are other tools for the professional developer, but this should meet our needs. We also want to write a while loop, and if you remember the pieces, their initialization. I want to have the current value, and it's going to start at the lower bound. I want my condition. Well, the condition is as long as the current value is less than or equal to, remember it's inclusive of the upper bound, we're going to continue doing the statements. And just to test out our while loop, we're going to output the current value, and that's all we need to do right now, followed by a new line. And then the last piece is to update the variables that affect the condition. In this case, we're going to add 1 to current. Well, I know that it won't pass the test, but I want to know if we've got our loop right. So let's run code. The test input is 8 and 11. We can look at C error, and yes, we read in as lower and upper bounds 8 and 11, so we're reading the input correctly. And we're outputting 8, 9, 10, and 11. Well, if we translated those correctly, we would have gotten the expected output. So it looks like our loop is correct. As I said, this looks very familiar, so let's not duplicate this code. Well, how can we avoid retyping this? It turns out that HackerRank has remembered your work. So I'm going to add another tab and go look at that. If you'll remember, it was in the conditional statements challenge. We can look at the challenge submissions here. That's all the code that we've uploaded to HackerRank. Your code will be here too. Click there. I happened to browse these earlier, so I know the one I'm looking for. You could poke around until you find the one you want. It is a success, which is good. We want code that works. And here it is. I'm just going to grab it all, and we can edit it when we get it. Since we did the functions challenge, I don't feel bad at all putting in a function here. I'm going to say the function translates a digit into English. And what should the function be? Well, first, it's just going to print and not return anything, so we'll make it void. And it's going to print a translation, so let's just say print translation is a good name. And we want to give it a number. It needs to know what to translate, and we'll give it int n since that's what it was already using. We're not going to get int n from standard in anymore. We're going to get it from the argument, and I'm going to say it is the color's responsibility not to give us bad values. So here's our translation. Now that we've got this translation in place, we can call that translation instead of cout. So we'll say print translation here, and we'll pass current. The value current here, the variable current here, its value will be copied, and n will be set to that, as we saw in the functions challenge. Let's see how we do. Anybody see a problem? Well, we had one. The first one is, this is a void function. It returned a value. In a void function that's simply going to finish the last statement, we don't need a return, but we can have a return if we need a return earlier in the function. So that's the first fix. Void functions can't return a value. And we didn't pass. Well, let's look at our output. What's wrong with it? Well, we got the digits right, but we didn't get the new lines. Well, this code didn't have the new lines because it only ever did one. We could change all of the outputs, but it's probably just easier to add it in one place. Remember, the new line is \n. Well, what else was wrong? Well, I said greater than 9 when I should have said even and odd. You'll notice that the function correctly said it was going to print greater than 9. Well, the documentation was right, but the function wasn't what we needed. So let's change both. First, let's change the documentation. Okay, we've got the documentation fixed. Let's come down to the case that's the greater than 9 case. Well, how do we determine whether the number is odd or even? We use the remainder operator. Remainder is going to be a variable I'm going to set equal to n remainder, or modulo, that's the percent sign, 2. So I want to know what is the remainder if I divide by 2. Well, there's only two possible values, 0 and 1, and so I can test that. If the remainder is non-zero, well, what does that mean? It means that it's not divisible evenly by 2, which would say that it is odd. Since there's only two possibilities, I don't need an additional test. And I can simply output even. Okay, let's try this. We've addressed both the issues. Let's see if we've addressed all the issues. Sure looks like it. Oh, another warning is don't leave your diagnostic print in. I've been bit by that. If you're done with a diagnostic print, comment it out, delete it. Let's test this against all the test cases. Well, let me show you a couple of errors that could occur here. One is if I had, and I actually did this in an earlier version of this, what if instead of testing remainder, I kind of lost my mind and tested n? Well, I'd see this result. I'd always see odd. Well, why is that? Remember, this is simply testing for whether a value is non-zero. And if it's a value greater than 9, then it's certainly non-zero, and we'll always see this first case. So that would be a symptom that you're doing either the remainder calculation wrong or that you're doing the if check wrong. Another possibility is, what if I didn't pay attention to the fact that we were looking at it to be inclusive of upper? This is what's known as an off by 1 error. Notice that we only see 8, 9, and even out, and we expected to see 8, 9, even, and odd. Well, since we are quitting this loop when current is equal to upper, because if current is equal to upper, it's certainly not less than upper, then we are not doing the final iteration. This is a pretty typical off by 1 error. We can fix that. And now let's turn this into a for loop, because this is a for loop challenge. Well, if you'll remember, the conditional, the initialization is the first clause, the condition is the second, and the increment or the update is the third. Let's see if we can just do that edit. For first expression, initialization. Second expression, condition. And third expression, update. Notice that it's exactly the same: initialization, comparison, and update. We can now get rid of the spurious leftovers. And the code is, in fact, 2 lines shorter than it was. And all the information about the loop is here present in 1 line. So for this style of loop, this is probably clearer than a while. Let's look at what these 3 expressions do. This is run before the first iteration. This is run before each iteration. And this is run after each iteration. So before I even do this comparison, I do my initialization. I then do a comparison before I run print translation, and I update current after I finish print translation, but before I look at the condition again. Again, we pass. Going back to that same error, what if I used a non-inclusive check? Well, then I would have to change the boundary by 1. I can use less than instead of less than or equal to by simply setting my upper limit to be 1 more than the last valid entry. And we'll see this use a lot when we look at arrays. Let's submit the code. Make sure we pass all the tests, and we do. Well, congratulations. Well, in our next episode, we'll be looking at arrays. And arrays and for loops go together like peanut butter and jelly, like mustard and hot dogs, Abbott and Costello. I don't know. Pick your thing, because for loops allow you to change through a set of values, and arrays allow you to look up variables by a value. That's going to be fun to do all together, and I'm looking forward to seeing you then. Until then, bye.